Hello everyone, you're watching Data Analytics Professionals and I'm Shanaz Malik. Let's quickly jump into today's lecture topic. Today we are going to discuss on advanced imputation technique and particularly we are going to talk about KNN. And this is lecture number 35 in this series and quickly check what we could learn. And until now, I have shown you the workflow to detect missing values many times. Once we are in hold of data, once the data is in our in our hands, and then we have to first check for missing values, and then once we check the missing values, we have to convert all missing values to null values. Maybe there are some other uh, symbols or some other characters, but we need to convert everything into null values, then analyze the amount and the type of missingness in the data. I have shown you how to do that, then appropriately delete where there is no other method where you think it's appropriate, but mostly we impute missing values. And for that we need to apply strategy, the right kind of strategy, and we are talking about those strategies, and we are at the same time trying to evaluate and compare the performance of treated imputed data set. But let's first apply the strategy and take it from there. Now, until now, as I said, we have learned a lot, including simple imputation techniques, and I've shown you many. And let's now learn about advanced imputation techniques using fancy impute package and make the most of our data set. Remember, datasets always have features which are correlated with each other, and it becomes really important to consider them as a factor for imputing missing values. Machine learning models use features in the data frame to find correlations and patterns and predict the selected feature. One of the simplest and the most efficient models is the KNN neighbors, KNN, and which is also known as K nearest neighbors. What it does basically, it finds K points most similar to the existing data points and then impute missing values according to these neighbors. Now, in simple imputation techniques, only one feature was used, and I have shown you. Only one feature was used to impute missing values. Using advanced imputation technique or techniques, we will be able to use multiple features to impute that missing values and to impute that missing value, or to impute missing values. So we will be using methods such as I said, KNN in this lecture, and in next lecture we will also have a look into mice, which is also known as multiple imputation by chained equations. So now to do all this, as all of you know, we need to open our Jupyter notebook and learn about these techniques. And in this case, as I said, let's go and have a look on in the our Jupyter notebook and see what KNN means for all of us. Okay, and how it works. Just to remind you guys, I will be in this lecture I will be just showing you how to use the KNN to impute missing values. But in future lecture at some point I will actually talk about the KNN in more in depth and show how this algorithm actually works, so that we will go into inside out of KNN and will come to know the back end of the KNN, the mathematics behind it. But at the moment we are just going to learn about how to impute missing values, because this is not a lecture about KNN inside out. We are not checking how it ends. We are not learning at the moment how it works at the back end. At the moment our goal is to learn how to impute missing values using KNN. So here I go. Now if you see, let's first save. So if you see, I am in the my notebook. So you can find this notebook in inside the folder, and it is named as strategies for imputing missing values, advanced imputation strategies, KNN. Okay, you should open this notebook, and and it will be in the where you can find, I will show you where you can find. So it will be in the project diabetes. Okay, so bear this in your mind. Now I'm going to run the first cell, and nothing will happen because this is just the heading. Then I'm going to say the second one, nothing will happen. This is my git hub link, and if to download all these files, you'll find them all there. Now this is just to set the Jupyter notebook width to 100%, so that I can use it maximum. Now see, my notebook has widened, and I'm using the max screen now. And on this line, yeah, I am just using import image from Python dot display, and that will help me to uh, get this image on this lovely notebook. And now all of you see that we are in the lecture number 35th. Okay, excellent. So now is the data acquisition. Okay, and this is just the heading, so nothing special here. All of you know by now, you should be aware of, if you have uh, mm, been with me from from the start of this lecture, you should by now know why we use NumPy and why we use Pandas. So here I'm importing Pandas and the NumPy, and I'm basically here using Pandas to read my CSV. So inside Pandas, we have a function called read underscore CSV, and that's used to actually, read the data, which is, and here just be careful that I have used diabetes with missing values. I have myself created some missing values inside it, just so that you guys have some practice to understand what kind of, so that you guys have a file with missing values, and then you could import missing values in it, and then learn some skills. Okay, now, and these are very important skills, and please bear this in mind. Now if I run this cell, and I can run it from here, or I can run, if I am highlighting this, I can do shift enter. Okay, and now it's run, and if you see, it's trying to fetch all the records, and that could be seen from here. If the star is there, it means it's doing its work. But now it's number 3, so it has done, no errors have been found, which means we all looks good. Now if I'm in this next line, and I'm shift entering on my keyboard, what I'm doing in this, basically I'm using the sample function to return a random sample of n items from an axis of the object, which is our data frame. Now if you see, the 10 will be in front of us, and let me quickly put it in a way so that you guys see it on the screen. And if you see, mostly, we haven't find any missing values here, except I think here is one. Okay, it shows that kind of our data set is kind of looks healthy, but this is just a sample to see what's inside your data, what kind of, for example, columns or features you have, and what kind of data is inside residing these features. Now the next one, I'm using info function, and so that I could see a concise summary of our data frame. Okay, it will also show me the index data type, column data type, non-null values, and memory usage, and so on. And again, I'm here going and doing shift enter, and you guys should be, you know By now you guys should be aware of this, but I'm just reminding it and repeating it. Maybe somebody is just come here and he or she only wants to see how to impute missing values, especially in advanced imputation techniques. So now if you see here, okay, I have features like uh, these features which we have seen at the top, but now we do also see, for example, this is C767 non-null values, and this is float. This shows us a data type. This shows us how many healthy records we have. So we have so many healthy records, but here we have less, and here we have really less, and it's 7 in comparison to 767. Here we have 7 to 9. But one thing to remember is the maximum is 768 entries, so we will have from 0 to 767 index. Okay. So you should compare this value with this value. Okay, so this looks totally healthy. Little bit missing values here, and there are some good missing values here, and so on. And for example, you see this is a healthy data set, as the entries we have 768 entries total in the data set. Okay, and here we have all these entries. So these features, these three features look really healthy. Okay, if you see what I mean. And now, as we have seen that there are some missing values, okay, here, and we need to check them. And before we check them, let's quickly print the description of the data frame. And okay, and here you can see how your some stats like mean, standard deviation, min, max, and some persons at 25th and 50 and 75th, all these values. And now let's come actually to the point where actually we are going to analyzing the missingness percentage of our and actually we are actually analyzing missingness percentage and missingness all of our data. Now we had data frame here. Our data is inside the data frame df, and I am now going to create a nullity data frame. Okay, and I'm going to name it df under nullity, and here it is. So I'm using is null function on the data frame, and then storing everything in the df underscore nullity. Now what will happen, we could use now this data frame. Okay, and just ahead, you know how to do it. It just prints the top. I have shown I need 10 rows. If you see n is equal to 10, so that's what I will get. I will get 10 observations from the top. And it's showing, for example, false. When you see false, that is good news. And if you see true, that is where we have missing values. But as you see, it looks fantastic, if we see like that, but that is not the actual way to find how much missingness we have. To calculate the missing total of missing values inside this df underscore nullity, we need to sum it, and we can print it then. And if you see run, and here it is. Now if you see, we have in Gilco's feature. Okay, we have 10 missing values. In diastolic we have 39, and so on. So now you have the numbers. You could see, as I said, these three data sets, dpf, age, and diabetes, looks healthy. They have all 0, 0, and 0 missing values, while others have some. Now to calculate the percentage of missingness, missing value, we need to check the percentage to also understand what kind of strategy we can, what kind of strategy will be best to do. The missingness tells us, should we delete the entire feature, or keep it and try to impute the missingness. Here we have a small data set, but just imagine you have millions and hundreds of millions of records, and you have to do this. Okay, and then these things, these skills that I'm showing you, these functions really come into play. Now calculate the percentage of missing values is simple. You give your nullity data frame and put the mean function in it and multiply it by 100, and that gives you the nullity percentage. And let's see, and that's what I'm doing. For I'm calculating the nullity percent, and then I'm just basically printing it. Nothing really difficult. It should be piece of cake for all of you guys by now, because I have discussed everything this I think in before videos at some point in previous videos. Okay, now here is the percentage. That's great to see. Okay, but we are these things I have shown you, I think, in the previous slides as well. But let's now talk about visualize missingness. And we have in previous lectures we have use Missingness and matplotlib. Okay, and from matplotlib we basically use pyplot as plt, and then use matplotlib pyplot from matplotlib to draw our a visualization. Now let's import all these libraries, and then once you see the star is still on, it means it's still importing these libraries. Now here it is, and I'm using this style. I'm just seeing what styles I have available. Just I keep this always on my notebook, so that maybe sometime it's better to know what kind of styles you could use. And here I'm picking the one from here. Okay, you could pick anyone. Now okay, I'm using this. This is just how my visualization will look. And here it is. Now I'm using missing no, and I'm using a function bar from it, giving the data frame that I have, and then basically plotting it. Should be a piece of cake. These are just arguments. Okay, and once I run this, and this gives you now the graphical representation. If for example it's 7 to 9, you see this gives a bar and showing how less it compares this with other features, which are with other healthy features. For example, this is healthy feature, this is healthy feature, and now you see so much data is missing here, and here a little bit missing, and there is one missing, and here also one missing, and here are two missing, and stuff like that. It gives us kind of graphical representation of what we are dealing with. Okay, and now if we plot the nullity matrix of df, and then that is we use from missing node, there is a function called matrix, and you give all other parameters, and which should be piece of cake for you. If you have any questions regarding that, please post your comments, and I will surely reply. And now if you see, it gives it gives us first of all, if you see, this is starting from 1 and to 7, 6, 8, and it shows you where the missing values are, a visual representation. So you see the missing values are mostly here, and some at top, and a little bit is scattered here, but they are mostly in this section. Okay, if you see, these will be these will be the indexes which will be mostly which will be mostly affected by missing values. It's nice, it gives us a good representation. Okay, and now if you move on further, now if we okay, I think I need diastolic. I need to sort it through diastolic. I don't know. Yeah, I'm sorting it through diastolic. Sort. So yeah, so I have to sort. What I'm just doing now, I'm picking this feature. I will sort everything through this feature. And if you see, sort diabetes data frame df on diastolic, and that's what I'm doing. So I'm putting my I'm using sort under values function on on my data frame, and then by showing by which value, and that's it, and that they will be sorted. And once they will be sorted, and then I will provide this to my matrix. And very simple, it kind of again gives you a graphical representation with respect to now missingness of diastolic. Okay, So it kind of shows us if we have missing values here, what's happening with the other values at same level. Okay, so once we have checked this correlation between missing data, okay, now we need to check the once we have sorted the value and had a graphical representation. Now correlations between missing data, okay, missingness. Remember, we could find correlation between missing data, and it helps us to gain a deeper understanding of the type of missing data. It also provides suitable ways in which the missing values can be addressed. So remember this stuff. So, and the correlation is very one of the very much liked and very much usable and easy to use actually function, which is called heat map, and it basically helps us to see the correlation between the features. And if I run this, here it is. Okay, so if it's going to be in this color, it's going to be good correlation, stronger correlation, and blue is somewhat, there is a correlation, but it's between, in area of this, and if it is greenish, stuff, or a little bit towards bluish, light blue, sky blue, and that means there's really little or no correlation. And here the down it goes, it shows the negative correlation. So if you see, there's a correlation between, it shows triceps and insulin has 0.7, and okay, that looks good. And there's 0.2 between pregnancies and diastolic and okay, so and rest is green, which means there's nothing much to say. There's no such rest is green. So what is green? Okay, so if it's green, it's a little bit towards negative, but not much to talk. But here surely we have this correlation, which is 0.7, and that looks some promising feature for us. Okay, now plot the missingness dendrogram of diabetes data frame. Okay, here it is. We have another function called dendrogram in Missingness, and then you provide the data frame, and method is average, and then you put other arguments, and they are pretty much if you don't know about the arguments, all you could do is go into documentation and read the documentation, and you will find everything there, what each argument means, but most of them are self-explanatory. Okay, now let's run this stuff, and we are coming to the meat of this lecture, so please bear with me. Now here is the dendrogram, and if you see, as I said, triceps and insulin perform creates a group, and which shows that they are correlated, and the closer the group, and that shows they are kind of correlated. And then this group is forming group with inside, this is forming one group, and this with is forming this. So it also gives you kind of which two features are closely correlated. And if you see here, triceps and insulin, a strong correlation, and if you see the same thing, you find it from here. Okay, and if you see diabetes, PF and age, they are in one group, and yeah, so, and they were also the healthy features. So this is dendrogram, and now there is the meat of this lecture. Is import. What we need to do, that import first KNN from fancy impute. This is your meat of the lecture. Okay, now from fancy impute, we will impute KNN, and then what we basically do, we copy diabetes to diabetes underscore KNN underscore imputed. Okay, now because we will use this data frame, so what we are just doing a deep copy and creating another we are creating another data frame, and which is pretty much similar of DF, and then we initialize KNN. The instance of KNN is initialized, and we assign that value to KNN underscore imputer. And then on this imputer, what we are doing, we are using the fit underscore transform function, and giving the database to it. Okay, once we give database, and what we are requesting here is this should be imputing values all rows and all columns. Okay, and that is what we are doing here. So imputing or impute using fit underscore transform on diabetes underscore KNN underscore imputed. We are doing this so that we have the original data frame is still as intact as it was. So okay, that's why we create the copy, and then on the copied df we are just imputing the missing values in all columns and in all rows. We could have excluded the our healthy data sets here, but those things I will talk a bit in depth in coming so to say lectures. What are the best ways to impute? Okay, so here I'm just showing you how you can just simply impute to all data frame, okay, to all columns and all rows. Now once we have this, once we have created, once we have imputed, so now here the values are already imputed. Okay, and I can run this, and if it takes a little bit of time depending on the data set, don't worry about these warnings. Okay, these warnings should not matter at this moment of time. We will discuss about these warnings when the time will come of what to do with that. It is just that some function gets old and upgraded functions are being introduced, and we might have to use one instead of the another. As you see here, it is simply future warning conversion of the second argument of if sub is sub d type from float to n floating is deprecated in future, it will be treated as np dot float 64 is equivalent to, okay, that compares to np d type float dot type. Okay, this is just these are just upgrades that happens. Some new versions do come, and they do updates in their packages, and we have to use the updated versions where we think it is necessary and where we think it is suiting our system which we have put in place. Okay, now talking about this, as you see, this the number has come in, so it has all done. If you see imputing rows from this with zero missing values, it took so much of time. Okay, and same thing happens if you see. So it's showing us how much time it takes, so what I mean to say, this is very good. It tells you how much resources you are using, how much time basically is used to impute missing values, and it counts when you have hundreds and millions of rows where you have to do all that. Now create and again, I'm now again pushing my this imputed database, database where the imputed values are. Now I'm checking, is there any null, using is null function just to check do we still have any null values inside it. And now here is the magic. You did just a little bit of stuff at the top. If you see, just imputed KNN, and then created an instance of it, and that instance you use the fit and transform method and function, and basically gave the argument as your the database where you want to impute the missing values, and that's it basically. It's so simple, so simple. It can't be simpler than this. And then here I'm just checking now what is the nullity inside my data frame. And here if I now run this, where I'm just summing up the nullity, and if you see, it's all now 0. There is no missing value inside our this data frame. Okay, which where we have imputed all missing values. And this is the greatness of the missing. This is how valuable is fancy impute, and especially KNN inside it. Very, really helpful, really easy to use. And I will show you use how to use all these packages in the coming projects, when we will take even bigger projects and some advanced level projects, and I will show how to use them. But at this stage, I think it's enough for all of you guys to understand how to use Missingness. I started from the start, so that if somebody has somebody comes into this lecture, and he only wants to if he only wants to know imputation technique, and then he can quickly jump into last section. But if somebody is new, he wants to learn from the scratch, then he has to understand how to first get into the data frame, connect to the data frame, check some stats. Once the stats are being checked, and then move into the missing values and calculate missingness, and then start plotting that missingness as I have shown, and as I'm showing you on the screen. Then once the missingness you have plotted, you have understood what is the missingness, sorted the missingness, checked the correlation of the missingness. Once all these things are done using different techniques, then you can move into this magic package, which is called fancy impute, and then impute the KNN from it. Once the KNN is imputed, then basically we keep original data set intact. We create another instance of a database with a deep with the argument deep is equal to true. And once we have that data set, I mean to say data frame in our hands, then we can use that data frame through with the KNN instance, and use what we do, we create a KNN instance first, then use its function, which is fit underscore transform, and give the argument as data as this data frame where we are ready to now impute values. And here I'm just giving iloc all rows and all columns, and then basically it does the magic for us. And then these two steps I have just to show you that it's all done. I hope that this lecture has been useful and really informative for all of those ladies and gentlemen who really want to see how the missing values are imputed in the data frame. But I have to request that please follow the other previous lectures, where I have shown the simple imputation techniques like mean, median, mod, and gone through the linear, quadratic, and other imputation techniques, and then come to here, because that is the whole package of how to convert these you need to know all these strategies to actually understand which strategy you could apply in a particular case, because sometimes a simple imputation technique can work. Backward fill, forward fills, they are all useful imputation techniques with respect to with respect to the problems. You face different problems, and you have different strategies in your hand. Of course, in future lecture we will discuss about in the coming lecture now we will discuss about mice, and I will see what more I could bring to you. But until then, if you like this video, please subscribe if you haven't until now, and please hit the notification bell so that you get notified as soon as I upload new videos. I hope to see all of you in my next video, which is extremely important for this, especially for this advanced imputation technique. And until then, I thank you all for watching. Data analytics professionals, and remember, sharing is caring. With that, it's time to say goodbye.